Today we're going to put all the stuff we've been working on all week all together into one assignment. Okay? So let's go over the steps for graphing rational functions. Okay? Do you have to do horizontal first even though I have it on the list first? No. Okay? Do you have to do vertical second even though it's on the list second? You can do whatever order that you want. I have these three up here just so we can give ourselves some reminders, some real quick hints. We're not going to put every single thing to do in this box. We're just going to give ourselves some hints of what to do when we're finding which kind of asymptote. Okay? So locate the horizontal asymptote. How do we do that? How do you find the horizontal asymptote? Yeah, absolutely look it up. I need you to know it. So remember by looking at your assignments. So we got to look at the exponents, right? So we're going to write look at exponents. Okay? Look at the exponents. That's how we're going to find the horizontal asymptotes. Now, is that all we have to do? No, that's just our hint of where to start. Okay? God bless you. If the degree of the numerator is greater, tell me about the horizontal asymptote. If the numerator is greater, there's not one, right? Okay, what if the denominator is greater? That's at y equals 0, right? What if the degrees are the same? You look at the leading coefficient, right? You look at the number at the very front, okay? So, you got that for horizontal? All right, what about vertical? How do we find vertical asymptotes? So we used to just say set the denominator equal to 0, right? That's what we used to say before we worked on removable discontinuities, right? So this is different now. First, what do I have to do for both of these two? What do I have to do first? Factor. So I'm going to write it right there because it's true for both of them. And we're saving a little ink or pencil lead. Okay? After we factor, we do want to set equal to 0 the factors only in the what? Denominator. Excellent. Set the factors equal to 0 that are only in the denominator. Okay? What about points of discontinuity? The removable discontinuity. What about that? So same thing. Set equal to 0 the factors in the numerator and the denominator. Okay? I want you to draw the asymptotes with dotted lines. I want you to make a table of important values. What exactly do I mean by important values? What's going to make it important? Typically like around the asymptotes, right? The x values, we want to choose x values that are around the asymptotes or around the discontinuities, right? Okay? But I'll show you what I mean when I do the sample problem for you right here, okay? Plot points and sketch the graph. I don't want just like, I want points from the table plotted onto the graph, and then identify your domain and range. Now, because they are in this order, does that mean you have to do them in this order? No, this is just all the things that I want to make sure that you do on this worksheet today. Okay, so let's look at the sample. We'll do the sample together and then you have the rest of them to do. Okay, I feel like I need to zoom in so you can actually see the numbers on this one because it would only print off very tiny. So I apologize for that. If you were an ant, it would be fine. Okay, so what do you want to do first? Your choice. Vertical asymptote? Okay, so how are we going to find vertical asymptotes? We got to factor first, okay? So if we factor this, so factoring the denominator is pretty cinchy, right? That's the difference of squares. So I just get x plus 4 and x minus 4. And if you didn't remember and if it's not cinchy to you, I apologize. I'm not trying to make you feel bad. Just the difference of squares is typically pretty easy to factor, okay? But if you didn't remember, hopefully I'm reminding you now. Okay? How do we factor the numerator? That's a little bit messier, right? Now, just for the record, sometimes you guys accuse me of only doing samples that are super easy, right? If you look at the next couple of problems, compare that with the sample. I'm doing a pretty tough one for you, aren't I? Okay, so how do I factor something like this? So I got to do AC and B, right? What's AC in this problem? 3 and negative 8, so negative 24, right? And what's B in this problem? Negative 10. So what two numbers multiply to be negative 24 and add to be negative 10? 6 and 4 do multiply to be 24, but if they're both negative to be negative 10, they would actually multiply to be positive 24. So 2 and negative 12, right? Okay, not trying to be tricky, that's just the problem we wrote, right? So we need 2 and we need negative 12. So we need to rewrite the numerator. 3x squared plus 2x minus 12x minus 8. And then we need to factor by grouping, exactly. What's common in these first two terms right here? X. If I factor out an x, what's left? 3x plus 2. Excellent. What do I need to factor out the second two terms? What's common in the second two? A 4 for sure, but we also need to take out a negative, right, to make our parentheses look exactly the same. So if I factor out a negative 4, what am I left with? Perfect. So what's common in these two terms? 3x plus 2. And what's left over if I factor out a 3x plus 2? X minus 4. Perfect. So that is what the numerator it is factored. Okay. So once I factor, what are we finding first again? Vertical? Okay. So do you mind if I first notice this? What's that going to tell me? My removable discontinuity, right? Okay. So how do I find my vertical asymptote then? It's this one, right? The only other thing left in the denominator is this one. So I set this equal to 0. X plus 4 equals 0. Subtract 4 from both sides. Where is my vertical asymptote? Perfect. And I'm going to go ahead and put that on the graph if that's okay with you. It crosses the x-axis at negative 4, so it's right there. Why do we draw asymptotes with dotted lines again? Yeah, they're not there. Okay? They're a placeholder for a place we know that nothing is allowed to be. Okay? Now what? What do you want to find next? Horizontal? Okay. So look at the problem. What do we look at first? The exponents. Tell me about the degrees. They are the same. So if they're the same, so y equals 3. So if I go ahead and put that on the graph as well, crossing the y-axis at 3. Okay. Now, yesterday, what did we call this? We called it a hole, but the real specific math name was what? Removable discontinuity. And all we did was found the x value, right? Today, we are going to take that one step further. First of all, let's find the x value. What is the x value? X equals 4, right? We're going to write it like this, because we actually want to know the point of discontinuity, not only the x value. If I know the x value, how could I find the y value? There's several different ways. Which way do you choose? What do you mean by solve? Plug it in for x. We could do that. That's one way. What's another way? I could look at the table, right? I could put this in the graph, the equation. So I put in 3x squared minus 10x minus 8 over x squared minus 16. So that helps me out. It'll help me out in a minute with the graph, right, to give me a good idea of what it should look like. But if I go Control T and look at the table, I just go down to 4. Uh-oh. Man, I knew that was going to happen. Did you know that was going to happen? Because it was what? A removable discontinuity? So didn't we know it was going to say undefined on there? So what do we do? We can't put undefined. We want to know exactly where that point is going to be. Okay? So if x equals 0, if x equals 4, do you have any idea what to do? Think about this. When we did our worksheet from yesterday, let me grab it real quick. Remember when we did this worksheet from yesterday? Yeah, this was our work from yesterday. This first example right here, we proved that these two were equal, right? And the only difference was is this had a common factor we could simplify, cancel out, right? So what if I took this equation that was here and simplified it? I already circled it, right? I already know that that's where I get my removable discontinuity. So shouldn't this equation right here be exactly the same as this without the removable discontinuity? So what if I plug 4 in right here? What's 3 times 4? 12 plus 2? So 14. What is 4 plus 4? 8. So what is 14 divided by 8? Any idea? We could simplify it, right, by 2, by a factor of 2. 7 over 4. So 1.75. This is a time where I don't really want to leave it as a fraction because that doesn't really tell me like where to go on the graph, does it? I really want the decimal here because that gives me a better idea of where to go on the graph. Are you okay with that? So what am I going to do right here at the point 4, 1.75, like right here? I'm going to draw a hole. That's what's there, isn't it? Do you want to go ahead and do domain and range, or do you want to do the table, or do you just want to finish out the graph? We kind of have to do the table first if we want to finish out the graph. And we already have our graph pulled up, our table pulled up on our calculator, so you want to go ahead and do that now? Okay, so here in this table, I gave you values, okay? But notice what values I gave you. -5, -4, -3. Why would I choose an x value of -4? What should it say right here? -4. Undefined, right? Because that's an asymptote. So I chose -4 on purpose because I knew that was an asymptote. So this is 13, and this is undefined. And this is, what, -3? -7? Sorry. Okay. Pretend that's a 7. Okay. And then why did I skip to 1? What did I want this time? I wanted to be around 4 because that's my point of discontinuity, right? Okay. So I just kind of skipped up to 1. 1 is 1. Oh, that's why, because it's a nice number, right? It's not a decimal like a whole bunch of these other ones are. Okay. 2 is 1 1/3. 1.3, I guess I should have put. And then 4 is undefined. And then 6 again is a nice number. It's not a decimal. Okay? So when I go to plot these on the graph, I get -5, 13. Well, can't really do that, can I? Because it's like way up here. I guess if I was careful, I could do it. Like way up there. 4 undefined. Don't put anything because I already have my asymptote there. -3. -7, again, not really on the graph, so I'm just kind of guessing. Okay. 1, 1. 2, 1 1/3. 6, 2. Now I know rational functions have its two parts based on this one asymptote, right? So I can use these points that I'm given plus the graph that I can see on my calculator to go ahead and draw but be careful not to draw anything through that hole that we wrote already, right? Okay, so far? So what do we have left? Domain and range. If I know where my vertical asymptotes and my points of discontinuity are, do I know where my domain is not? Okay, so where is my domain not? -4, +4. Okay, so first of all real, x is not equal to -4 or +4. Look, I put the comma before, that's weird. How do I write it in interval notation? -4 union to +4. Nope, that's right. And then again from 4 to infinity. Okay. If I know where my horizontal asymptote is, do I know where my range is not? Yes. Okay, so where is my range not? At 3. So all real, but y doesn't equal 3. So what does that look like in interval notation? Yep. There's only one restriction here, so there's only one union here. 2 restrictions cause 2 unions to happen. Okay? So there's your sample. How do you feel about this? All right, so you have 10 problems to do for homework. Okay? I do want to point out 2 of these problems specifically. Okay? Glance through real quick. Glance through at them. Everything's pretty okay, right? And then you get to the back. Look at 9 and 10. Look at the equation I gave you. Look what it says. Create your own function that has at least one vertical asymptote and no holes. So what are you going to have to make sure of on that one? Yeah, nothing can cancel out. Okay, you got to have at least one vertical asymptote but no holes. So nothing can simplify like this. Okay, and then look at number 10. Again, you're creating your own function that has at least one vertical asymptote and one hole. At least one. Okay, so you are going to have to make sure to have something that cancels out like this. Okay, any questions? I do want to be clear though. Notice number 6. See how in a lot of these other ones, like number 5, you had to factor it first? Notice that number 6 is already factored for you. Okay? It's your choice how you write your problem on 9 and 10. You can write it already factored, or you can write it so where somebody would have to factor it before they did the problem. That's up to you. Okay? Any questions?